Well, the building services allow us to operate the building. So that you can have walls, floors, roofs, windows and so on, but they don't necessarily provide every function that a building needs. So, for instance, in this particular building, we are looking to provide artificial lighting, for instance. And in this instance, the ideal solution is to provide LED lighting, which is very low energy but provides a lot of light. So it reduces the energy costs for the building. But also in this building we have an MVHR system, and that allows us to ventilate the building with fresh air, but also to reclaim the heat from that fresh air before it's actually expelled to the exterior. So it provides a healthy, filtered air experience for users of the building. From the lighting point of view, we have also presence sensors. So that obviously turns the lighting on and off when people are entering the room. In fact, every room in this building has presence sensors apart from the plant room area, which is a more service area anyway. So we reduce energy use via that method as well. Plus, the design of this room has natural lighting from both sides, so the need for lighting is reduced during the daytime anyway. We have, on the south side of the building, we have a very large curtain wall which is designed and constructed to Passivhaus standards. We have a slot ventilator in the ceiling which which brings fresh air into the room, which is preheated, and then it transfers across the room to the north elevation where we have an extraction grill, so that they're both connected to the MVHR units, which are, in this instance, in a store cupboard of the room. In operating the system in this particular room, we also have a CO2 sensor which can test how many people there are in this room at any one time. If there's a crowd of people, then you need more ventilation. So it'll boost the ventilation system to cope with that. It also has a thermostat to make sure that the room temperature is at the right level. Semi-commercial kitchens within Passivhaus design, it's more difficult to manage than it would be within a domestic house, principally because the kitchen is used most of the day. The amount of heat that's produced within the kitchen, then you have to cope with that by extracting it from the kitchen area. In this instance, we've introduced two MVHR units, both of which manage the kitchen and the cafe area, extracting air from it. Similar to the room we're standing in, which is the community room, the cafe has a similar approach, in that the fresh air is introduced through one of the walls at high level. That then is transferred across the kitchen, across the cafe area through the kitchen, and is extracted by the actual hood over the induction hob. Yeah, this building was designed to have 28 PV panels as part of a roofing system. The client is looking to increase that. The existing array is 28 panels and it produces just over 9 kilowatt peak. The client is looking to double that, so we would be up to 18 kilowatt peak, which would be a fantastic boost to the actual energy performance of the building. With regard to heat for the building, both in terms of space heating and domestic hot water, the space heating and hot water are provided by an air source heat pump, which has an external compressor, which is to the west gable of the building, and that is then connected to the plant room, which has a compressor within it. And this actually allows us to extract heat from the air, and that is then transferred via the compressor within the plant room to heat energy. And effectively, by putting 1 kilowatt of electrical energy into the system, we get 2 to 3 kilowatts of heat energy out of the system, so it's very efficient. And that allows us to both heat the interior air of the building, the space, but also the hot water, which is contained within a storage tank within the plant room.